Hello everyone and welcome back to the Pondering Philomath. In this video, I will be explaining a topic from the chapter of geometry, namely the circle properties. In this topic, there are about 4 to 5 rules that you will need to learn, and I have divided them in 2 videos, or in 2 parts, so don't forget to look at the second part as well. But for now, let's get started. So the first rule that we have, it states that the sum of the opposite angles in a cyclic quadrilateral is equal to 180 degrees. First of all, when do we even use this rule? Now, this rule would be used when you have a cyclic quadrilateral in the problem. And what is a cyclic quadrilateral? Well, it is quite simply a quadrilateral inside a circle. Now, how do we see that? Well, if you have a shape inside a circle which has 4 vertices and 4 sides, like over here, and where each vertex must touch the edge of the circle, right? So each of these vertices is touching the edge of the circle. So this is a quadrilateral, a cyclic quadrilateral. Now, even if one of the vertex does not touch the edge or the circumference of the circle, then it is not a cyclic quadrilateral, and this rule cannot be used. In that case, you will need to look at the diagram carefully and use another rule from the list. Now let's look at this problem and try solving it using this rule. All right, so here we have a circle, and inside the circle we have a cyclic quadrilateral. And we're given 2 angles. Over here we have 92 degrees, and over here we have 103 degrees. And we are asked to find A and B. Now the rule states that the sum of the opposite angles, right, this is important, the opposite angles in a cyclic quadrilateral equal 180 degrees. And what are opposite angles? In this case, it is this angle and this angle. So this is one pair of opposite angles, and 92 degrees and B, that makes another pair of opposite angles. So because in this pair we already know one of the values, which is 92 degrees, then let's get started by finding out B. Right. So the first step we have, using this rule, we can say that 92 degrees plus B is equal to 180 degrees. From that, we know that B is equal to 180 degrees minus 92 degrees, which would be 88 degrees, right? So then we have found B, which is 88 degrees. And then we have to find A, but as we see, we're not given the angle over here, which is supposed to be opposite to it. But thankfully, we're given the angle over here, which is 103 degrees. And we know that on a straight line, like over here, the angles have to add up to 180 degrees, right? So we can say we have to find this angle, and let's just name it C, right? So using the same rule again, we can say that A plus C has to be 180 degrees. Let's just calculate C really quickly. So that would be 180 degrees minus 103 degrees, and that would be 77 degrees, right? And we'll just put it over here, and I'll just rearrange it quickly. So that would be 180 degrees minus C, and C is 77 degrees, and that would give us 103 degrees. So, final answer, we have A is equal to 103 degrees, and we have B is equal to 88 degrees. Good, so that was the first rule, and now let's move on to the second one. And the second rule says that the angle at the center is 2 times as big as the angle at the edge or the circumference of the circle. So it's the same thing, edge. You can call it edge, or you can call it the circumference, right? And the angle of the middle lies over here, and the middle of the circle is often stated by an O, like over here, and this is our center. So when do we use this rule? When there is an angle at the center and another angle at the boundary of the circle, and one of them is known, and the other one is to be calculated. So yeah, let's just dive into this example. We're given a circle. We're also given the center of the circle and the angle at the center of the circle. And we have a couple angles which we need to find out, which are located at the circumference of the circle, right? So that is angle A and angle B, or we can say PSR or PQR. Now, how do we go on to solve it? Again, let's just look at the rule. So the angle at the center is 150 degrees. And that is supposed to be twice as big as the angle at the edge. Now here, what I like to do is, I like to take the starting points, which is P and R. And let me explain how. So P and R are the starting and the end points of this angle, the angle at the center. You can see over here, we have the angle at the center starting at P and ending at R. And then we look at angle A. For angle A, it's again the same combination. So we have angle A starting at P and ending at R. And the same is valid for angle B, right? So for this is how I like to notice how we can use this rule. So they always have to have the angle at the center has to have the same starting and ending points as the angle at the edge, right? So this is like a trick I use. But now let's actually use the rule. So the first one, we have to find PSR. And actually, you can see it directly that both of these angles are going to be the same because they both have the same angle at the center of the circle, and they both lie at the edge of the circle and have the same starting and end points. So then we have PSR is equal to PQR, and both of them are going to be half as big as 150 degrees. So that would be 150 divided by 2, and that would be 75 degrees. So both A and B are going to be 75 degrees. Now, to this rule, there's also a sub-rule that we need to know. Now, the sub-rule is actually the same as the previous rule, or it can be derived by it, because what we have here is that the angle at the center is 180 degrees. And you can visualize this as increasing the angle between the two radii until they make a straight line, so 180 degrees. And from the last rule, we know that if the angle at the center is 180 degrees, then the angle at the edge of the circle must be half of it. And in this case, specifically, 90 degrees. So this is just a special form of this rule. What this means now is that this isn't really a separate rule, and so you actually would be sufficient for you to learn the previous rule, and this way you would have one less rule to learn. But the reason why I have it here as a separate sub-rule is because it may be hard to see that the previous rule applies here. So just, if you're comfortable with it, then you can just leave it out. So, right, let's just get to it. Okay, so this here, we notice this is a diameter. And it has to be a diameter in this case because it's passing through the center of the circle. And the rule says that the angle in a semicircle, so obviously this is a diameter, and here we have a semicircle. The angle in a semicircle, which angle do they mean? This is the angle in a semicircle, right? We have a semicircle over here. This part is our semicircle. Oops, sorry. Yeah, you know, this here. So that is the semicircle. Ignore this. This is also a semicircle, but we're not dealing with it. So we're looking at this semicircle. And the angle in the semicircle is 90 degrees. So this angle over here is 90 degrees. And we know that the rule is the angles inside a triangle have to add up to 180 degrees. And so it is quite easy to find out the A from this. So we have 180 degrees is equal to the sum of all of these angles. So that is A plus 73 degrees plus 90 degrees. And let's just rearrange it a little bit. So we have 180 degrees minus, if we calculate this, so that would be 163 degrees. and that gives us 17 degrees for A. So these were the first two rules and a little sub-rule there. Now let's move on to the third rule. And the third rule states that the angles subtended by an arc in the same segment of a circle are equal. Now this rule sounds complicated, but actually there are only two parts to it that you need to consider. The first one, let me just write it down. The start and the end points must be the same. So just like I looked at over there. So start and end points have to be the same. And the second part is that the angles must be in the same segment. So angles in same segment, right? Okay, and I will quickly explain number 2 and what a segment is. So in a circle, if we draw a chord is just any line. A diameter is a special chord because it passes through the center of the circle. So any line which connects 2 points on a circle, inside a circle. So in a circle, if we draw a chord through the circle, then it is the circle is divided in 2 segments. It is, for once, in the major segment. So let's just look at this chord, AC, right? And just ignore all the other lines. So this is a chord, and it's dividing the circle into a smaller part and a bigger part. And just to be fancy, the smaller part is called the minor segment, and the bigger part is called the major segment. So those are segments. Now let us understand this rule through the example, right? So what do we have? We have angle C, A, and D is given as 27 degrees, right? I hope you see it. So this is C, A, and D. This angle is 27 degrees. Then angle C, B, and D is the one that we're looking for, and that is in this case B. Now notice that both of these angles have the same starting and end points, which is C and D over here as well, right? And because of that, they are equal. So that's quite easy. B is 27 degrees, right? Now let's look at C, right? Where do we have C? Over here. So for C, we have starting point is A. You can even take B as a starting point. It doesn't really matter. You just have to be consistent with it. But let's just take A. So ADB is 30 degrees over here. ADB. And ACB is angle C, the one that we're looking for. And again, they have the same starting and end points. So C is equal to 30 degrees. Now this works even if there is no chord dividing the circle. And you can just imagine a chord because you don't really need the chord for the calculation, but only to see if the angles are in the same segment or not. So that is it for the first part. And do make sure to check out the second part. And if you found it helpful, then consider subscribing to the channel. Thank you.